Dear students and my teacher friends, Namaskar. I welcome you to the presentation lecture on the Renin Angiotensin Aldosterone mechanism. Now, what is this mechanism? What are the learning objective for this lecture? See, in this lecture, we are going to discuss that sometimes in our body blood pressure drops. So when the blood pressure drops, that time this mechanism act in our body to restore the normal blood pressure or the to elevate the normal blood pressure. This renin angiotensin aldosterone mechanism is working in our body to restore the dropped blood pressure. Okay, and there are chain of events associated with this mechanism. So which are this chain of events that we are going to discuss now? Okay, starting with the first point. See, in this mechanism sometimes a person may encounter the accident, so that time it is possible that person is suffering from severe blood loss. Okay, and sometime if the, let's say, in a dehydration condition, for example, person is walking on a road in a summer season, so that time excess amount of water is lost from the body, so we can say the person is dehydrated, okay, due to the loss of the water from the body. So when the person is suffering from bleeding or person is suffering from dehydration, that time in the body blood pressure drops. Okay, now it is very important to restore this drop blood pressure. So one by one we are discussing all the process involved. First, when the blood drop, uh, this blood pressure drop is detected by baroreceptor, and baroreceptors are present in aorta and carotid arteries. So the baroreceptor, they detect that in the body blood pressure has dropped. Okay, so here you can see from the blood vessel blood is coming out, so due to that blood pressure has decreased in the body. Now the second point. Now the baroreceptor, they transmit a signal to the brainstem. Brainstem interpreted this signal that blood pressure in the body has decreased, and now the brainstem brainstem sends sympathetic reflexes, which are the corrective one. Okay, so from the brainstem there arise the corrective sympathetic reflexes. And what are these reflexes? See, one such reflex is that sympathetic fiber, they innervate, they connect with the granular cell, also known as juxtaglomerular cell. So when the sympathetic fiber, when they when they synapse with the granular cell secrete enzyme renin. Okay, so from the brainstem various corrective sympathetic reflexes are there. One such reflex is the sympathetic fiber stimulating the granular cell, and this granular cell, they secrete enzyme renin. So here in the figure, as you can see over here, this one is the sympathetic fiber is shown, and as you can see these are the granular cell, and with the granular cell the sympathetic fiber connects, making the synapse. Okay, and now when the signals are transmitted to the granular cell, now the granular cell, they are secreting the enzyme renin. Okay, now where this enzyme renin is going, where it is acting, so let me show you this figure. Okay, So now we are discussing the third point. Now, enzyme renin acts on angiotensinogen. Angiotensinogen is a protein which is present in blood plasma. In the structure of angiotensin, there are present 453 amino acid. So we can say angiotensinogen, a protein, is 453 amino acid long. So renin is acting on angiotensinogen, and due to the action of renin, this angiotensin is split off to a 10 amino acid peptide, and this 10 amino acid peptide is known as angiotensin 1. So simply we can say renin is acting on angiotensinogen. So most of the amino acids are removed and only few left, only 10 amino acids are left. So the peptide chain with the 10 amino acid is known as angiotensin 1. Okay, now renin converts inactive plasma protein angiotensinogen, okay, and this angiotensinogen into angiotensin 1. Renin is acting on angiotensinogen and converting into angiotensin 1, and this angiotensinogen is made in the liver. Okay, so the production of angiotensinogen takes place in the liver, and renin is converting this inactive plasma protein angiotensinogen into angiotensin 1. So now we are having angiotensin 1. Okay, now in the lungs and kidneys, this angiotensinogen is acted upon by the enzyme ACE. Okay, so enzyme ACE, angiotensin converting enzyme, removes 2 more amino acid from the angiotensin 1. So angiotensin 1 is converted into angiotensin 2. Now this angiotensin 2 is a hormone, and this hormone acts in a several way, and this hormone restores fluid volume, and this hormone also restored the blood pressure. So this angiotensin 2 hormone is normalizing the blood pressure. Okay, and also the this hormone is restoring the body fluid. Okay, the volume of the blood. Okay, so here in this figure you can see angiotensin 1, which is having 10 amino acid, and now it is acted upon by the enzyme angiotensin converting enzyme ACE. So now ACE acting upon angiotensin 1, and angiotensin 1 is converted into angiotensin 2, and this angiotensin 2 is having 8 amino acid. Now we are having angiotensin 2. Now where this hormone is acting. So as you can see in the figure, angiotensin 2 is a potent vasoconstrictor. Okay, that means it is responsible for the constriction of blood vessel, and as the blood vessels of the body are constricted, So the mean arterial blood pressure raises in our body. So once again, one action of angiotensin 2, that it act upon the blood vessels of the body. So due to that, the blood vessel constrict, and as the blood vessel constrict, so due to the constriction of blood vessel, the blood pressure rises in the body. Okay, so this is the one way this is the one way that the blood pressure is elevated. Now we are discussing the other ways by which the blood pressure is elevated by angiotensin 2. Okay, so now we are discussing the seventh point. Now in this figure, first you see this anatomy of the glomerulus is shown. Okay, see the Bowman capsule they are showing, basement membrane, parietal epithelium. Okay, so inside the Bowman capsule, okay, the tuft of capillary is there. So these capillaries are, we know, glomerulus. These all capillaries are glomerulus, and these capillaries, they are supplied by the blood. So it is the afferent arteriole, we know, afferent arteriole, which brings the blood in this glomerulus. Okay, now from the glomerulus, the blood enters into the efferent arteriole. Okay, so now we are having angiotensin 2, and this hormone acting in the kidney. So inside the kidney, this hormone act on afferent arteriole. Okay, and also this hormone act on afferent arteriole. So efferent arteriole and afferent arteriole, both of them, they are acted upon by the hormone angiotensin 2. Now due to the action of angiotensin 2, afferent arteriole constrict, and efferent arteriole is constricting. Okay, and afferent arteriole is also constricted, but somewhat lesser degree. So now what happened? See, now the pressure inside the glomeruli, okay, so the pressure in this blood capillary, in this glomerulus, increases. Okay, so why the pressure is increasing? See, by constricting the glomerular outlet, that means the constriction of efferent arteriole. Okay, so constricting the glomerular outlet more than the inlet, so afferent arteriole is less constricted, efferent arteriole is more constricted. So that's why what happened, due to this, the pressure in the glomerulus increases, and as the pressure increases, the pressure means the glomerular blood pressure increases. So now the components of the blood, they comes out from this tuft of capillaries, glomerulus, and the component which filter out from the blood, these filtered substances or the components of the blood, they are now known as glomerular filtrate. So as the pressure is high, GFR, glomerular filtration rate is raised. GFR, the filtrate formation is increased. Okay, and angiotensin 2 hormone also responsible to prevent a drastic reduction in GFR. So the hormone is maintaining the normal GFR, glomerular filtration rate. Okay, so now thus ensuring continued filtration of waste from the blood. So the filtrate is continuously produced. Okay, and even when blood pressure has fallen. Okay, so we know the blood pressure, when the blood pressure fall, that time what this angiotensin 2 is doing. So it has contracted the afferent arteriole and to lesser extent the afferent arteriole, due to which what is happening, the pressure in the glomerulus is increasing and the filtrate comes out, that is glomerular filtrate. Okay, so by this glomerular filtration rate is maintained and angiotensin 2 is not allowing the drastic reduction in GFR. So the hormone is responsible for the maintenance of normal GFR. So now as the enough amount of GFR is there and enough glomerular filtrate is produced, so now the normal urine formation is going on and removal of waste from the body is also going on even when the blood pressure is low. Okay, so this is the 7th point. Okay, now the 8th point. Now constriction of the afferent arteriole lowers blood pressure in the peritubular capillaries. Now what are peritubular capillaries? See, this is the nephron and the capillary network which is present around this nephron is known as peritubular capillary. Okay, so due to the effect of hormone angiotensin 2, efferent arteriole is constricted and now in the peritubular capillary blood pressure is decreasing. Now normally in normal condition the blood pressure of peritubular capillary opposes fluid reabsorption, but here in this case, since the angiotensin 2 is acting upon the efferent arteriole is constricted, so due to that the pressure in the peritubular capillary is decreased. So now this will favor the reabsorption. So now the peritubular capillaries, they are now reabsorbing NaCl and water from the filtrate. So in the nephron, you can understand from the PCT, first PCT, then loop of Henle, okay, then DCT, and then collecting duct. So when the filtrate is moving, in the nephron, so on the surface of the nephron, okay, on all the part, peritubular capillary is there, overlying on the nephron. So Now the NaCl is going to enter into peritubular capillary, and which is going to followed by water. So sodium chloride and water is entering into the peritubular capillaries. So now when the NaCl and water enters into the peritubular capillary blood, so now the blood volume increases. Okay, so now as you can see, more water is returned to the bloodstream instead of being lost in the urine, because water is absorbed from the nephron and water and NaCl entered into the peritubular capillary blood. Okay, so this is the eighth point of our discussion. Now we are discussing the ninth point. Now here in this figure, okay, renin, we know this conversion angiotensin 2. How now angiotensin 2, here you can see angiotensin 2 acting on adrenal cortex. So now angiotensin 2, as we have seen, stimulating adrenal cortex. So now adrenal cortex secrete aldosterone. Okay, and this aldosterone, see over here, okay, these are all the effect of aldosterone. So now what this aldosterone is doing, so first of all, you see this is the nephron. Okay, here the Bowman capsule is shown. This is the PCT nephron loop. This is the DCT. Okay, so now due to the effect of angiotensin 2 on adrenal cortex secrete hormone aldosterone. Now this aldosterone promotes sodium and water reabsorption by the distal convoluted tubule DCT. From the DCT, due to the action of aldosterone, Na plus and water are reabsorbed, and also from the collecting duct. So here you can see from the adrenal cortex aldosterone is shown. Now due to the effect of aldosterone, see from the DCT, Na plus are entering into peritubular capillary, water is entering into the capillary. Okay, now angiotensin 2 also directly stimulates sodium and water reabsorption. Na plus and water are reabsorbed in the PCT. So directly angiotensin 2 directly act on PCT, and from the PCT Na plus and water enter into the peritubular capillary. Okay, so now as the water is once again entering in the blood, so now the blood volume is increasing and the blood pressure normalizing. Okay, so I'm showing you this entire figure. Okay. Now the hormone angiotensin 2 also act on posterior pituitary gland. So posterior pituitary gland secrete anti diuretic hormone, ADH. Angiotensin 2 also acting on posterior pituitary gland secreting antidiuretic hormone, ADH. And now where this ADH is acting? So ADH is acting on collecting duct, and ADH promotes water reabsorption from the collecting duct. So here you can see this is the ADH and these are the arrows they are showing. So, and here you can see this is the collecting duct they are showing. So see, Na plus and H2O. Okay, so Na plus reabsorb and water reabsorb from the collecting duct. So this entire figure, sure. Then angiotensin 2 also stimulate the sense of thirst. So angiotensin 2 act on the thirst center which is located in hypothalamus. So we are having the urge to drink water. Okay, so when we drink the water, so due to this also blood volume increases and blood pressure normalizes. Okay, so collectively due to this renin angiotensin mechanism, what is happening? So the blood pressure is once again restored. Blood pressure is elevated in the body by reducing water loss, encouraging water intake, drinking of water, okay, and constricting the blood vessels. Now I would like to show you the figures. See, this is the concept map. This is the concept map for the renin angiotensin aldosterone mechanism. Okay, we have already discussed. See, this is now the effect of angiotensin 2, and here you can see elevated blood pressure. Regulation of the glomerular filtration rate. Okay, here also in this concept map, in this figure, see, point wise they have given all the information, so you can go through this information 1 2 3 4 5 points and you can look at the figure. So if you have some doubt, you can clear your doubts. Okay, now this is also the same thing. Okay. See how the blood pressure normalize. So was vasoconstriction and Na plus and H2O retention reabsorption process in the kidney. Summary of the renin angiotensin system. Okay. Now this is also very handy concept map, and this concept map explain the entire process. So with this concept map you can prepare the entire topic of renin angiotensin aldosterone system. See, one by one all the steps they have shown, and very beautiful concept map. Okay, very easy to understand. See, from the liver, angiotensinogen from the liver entering into the blood. Now see, systemic blood pressure decreases. Okay, so the receptor and the sympathetic reflex, sympathetic fiber innervate the granular cell. Okay, now see here the JG cell, they are secreting enzyme renin. Renin enters in the blood. In the blood, renin act on angiotensinogen. Angiotensinogen converted into angiotensin 1. From the lung and kidney, ACE enzyme acting on angiotensin 1. Angiotensin 1 is converted into angiotensin 2. Okay, now angiotensin 2, where it is acting. So see here on the thirst center, which is located in the hypothalamus. So we are having urge to drink the water. So fluid intake normalizes the blood pressure. Then here you can see constriction of afferent and efferent arteriole. So GFR is increasing. Okay, then promoting the vasoconstriction of the systemic blood vessel, then promoting the reabsorption of Na plus and Cl minus from the proximal tubule. Water follows, promotes aldosterone release increasing, and this aldosterone increasing Na plus and H2O reabsorption. Okay, so see here, okay, aldosterone. So all this point we have already discussed, but anyway you can go through, you can prepare with this chart also. Now here in this figure, okay, you can understand also from this. Okay, see renin, blood pressure decreasing, renin acting on angiotensin 1, angiotensin 2, aldosterone. Okay, so with this we have completed this lecture on the renin angiotensin aldosterone mechanism. I hope you have enjoyed this lecture, and I also hope that this lecture will be helpful in your exam preparation and also in your studies. My name is Manish Kushti sir. I am from Ahmedabad, India. Bye bye. Namaste.